Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. S_N1 reactivity depends on the stability of the carbocation formed after ionization, loss of the leaving group. More stable carbocations form faster, giving higher S_N1 reactivity. Carbocation stability order: allylic benzylic tertiary secondary primary. Moving on to the next step. Compound 1N-butyl chloride primary alkyl chloride. Upon ionization it forms a primary carbocation, which is very unstable. S_N1 reactivity very low. Compound 2CH2 is equal to CH, CHCl, CH3 secondary allylic chloride. Upon ionization it forms a secondary allylic carbocation stabilized by resonance with the double bond CH2 is equal to CHCH plus CH3 plus CH2 CH is equal to CH3. Allylic stabilization makes this carbocation significantly more stable. S_N1 reactivity highest. Compound 3. The structure shown is a secondary alkyl chloride, isobutyl secbutyl type, no allylic or benzylic stabilization. Upon ionization it forms a secondary carbocation, which is more stable than primary but less stable than allylic secondary. S_N1 reactivity intermediate. Moving on to the next step. Compound 2 secondary allylic carbocation, compound 3 secondary carbocation, compound 1 primary carbocation. This gives the decreasing order 2-3-1. And for the final step. A 1-3 incorrect primary carbocation is least stable. C 2-1-3 incorrect primary 1 is less reactive than secondary 3. D 3-1 incorrect allylic stabilization makes 2 more reactive than simple secondary 3. Therefore, the correct answer is B. Therefore, the correct answer is option B.